Okay, so we are going to review quadratic equations, and remember that a quadratic equation is a polynomial of degree 2, okay? And there are three different main forms you're going to see quadratic equations in. The most typical form for a quadratic formula, a quadratic equation is ax squared plus bx plus c, okay? That's the most common way that we're going to see it. And when we're in that form, we can get the x value of the vertex by substituting x equals negative b over 2a. Okay, so this b and this a, okay, negative b over 2a. That'll give you the x value of your vertex. Once you get that, you'll have to substitute in that value into the function to get the y value of your vertex. Okay, the second form that we have seen quadratics in is a times, and let's actually choose different variables here, and then b. Let's use p and q. IB likes those letters for this. Okay, a times x minus p times x minus q. That's our factored form. When we're in that form, we can easily see the two zeros, p comma 0 and q comma 0. Those are our x-intercepts. Remember that zeros, x-intercepts, roots, those all mean the same thing. Okay, and then the last form that we've really talked about a lot looks like this. And that is our vertex form. We call it our vertex form because we can actually see the vertex straight away from that form. Okay, so we can see here's our vertex, h comma k. Don't forget, since the vertex form has this minus in here, if it says x minus 3, then the x value of our vertex is positive 3. If it says x plus 3, the x value of our vertex is negative 3. Okay, k, though, keeps its sign. So if it says plus 5, y value of the vertex is 5. So these are our three forms. They're all useful in different ways. The main one, we can do, we really can't do all that much with the main one just by looking at it. We can do a lot with it using the quadratic formula or using this formula for our vertex, but just looking at it, all we can really tell is where does this quadratic open up or down based on positive or negative, and we can see the y-intercept in it right here, okay, right? Because when we plug in 0 for x, that leaves us with the y-intercept of 0 comma c. So we can see whether it opens up or down, and we can see the y-intercept. The factored form, we can see the zeros, and we can also see whether it opens up or down. And then in vertex form, we can see the vertex, which is always really useful. We can also tell if it opens up or down. Okay, so our three different forms, we can see different things. We should be able to convert between these three forms. So in order to go from here to here, you'd factor. And in order to go from here to here, you'd FOIL, you'd distribute. Okay? In order to go, let's say, from here to here, you would have to FOIL this out and then combine it with the a and the k. Okay, so you'd basically distribute it all out and then combine like terms. To get from our standard form to our vertex form, you're going to do what's called completing the square, and we're going to review a problem to help you guys jog your memory about that. And then, honestly, if you're going from vertex form to factored form, I'm pretty sure that the easiest way is to go from vertex form to standard form and then to factor it from there. Okay, so we should be able to convert between all three ways. Now, there are three ways to solve a quadratic equation. And so what I mean by solve is that you may have something like this, 3x squared plus 2x minus 1 equals 0. Okay, solve means solving for that x value, okay, which would also happen to be the zeros or the roots. Now, in terms of solving, there's 3 ways that we've learned how to solve. And so the first way is to use the quadratic formula. That's always going to work. You have to know the quadratic formula, but it's not always the easiest way, okay? Completing the square is also going to always work. And if you know that method is one of the most versatile ways because it helps you put a quadratic function into vertex form, so it helps you see the vertex, and then it also can help you solve for the zeros. So it's useful in several ways. And then the third way doesn't always work. We can't always factor an equation. If there's not rational roots, then we can't factor it. But factoring is usually the fastest way, so if it factors, that's usually your best bet. Now, there's something that we need to talk about specifically with the quadratic formula. Okay? And with the quadratic formula, we are just substituting in our A, B, and C. But what's really special about the quadratic formula is this part right here, and that has a special name. It's called the discriminant, and we use a triangle to represent it. The root is not a part of it, it's just what's under the root. Okay, so just the b squared minus 4ac. And the discriminant is really unique because that's the part that's after this plus or minus. So if the discriminant is 0, something different is going to happen than if the discriminant is positive, than if the discriminant is negative. So let's talk about those 3 options. If the discriminant is equal to 0, that means that when you add a 0 or subtract a 0, it's not changing your answer. And so you only have what we call one distinct root. Distinct meaning unique roots. Okay? Now, some people call that 2 equal roots because when you add 0 and when you subtract 0, you get the same thing. So they're equal roots. Okay? So one distinct root or 2 equal roots. If the discriminant is positive, then when we add the square root of that number versus subtracting the square root of that number, we're going to get different roots. So we're going to get 2 distinct roots. And then if the discriminant is negative, we are going to have a negative that's under a square root. And when that happens, that's an imaginary root. So we have 0 real roots, only imaginary roots. Okay? So those are the unique things that happen because of the discriminant. And IB loves to ask you about the discriminant, and you'll see an example of that on the next page. Okay, so let's go ahead and look at that. So I was just saying that IB loves to ask you about the discriminant, and so here's a perfect example. It gives us this quadratic equation, but it's not complete. They have k, a constant, in there. And they tell us that it has 2 equal roots. So we have to think back to our discriminant and what would make it have 2 equal roots. And again, remember we said 2 equal roots is the same as 1 distinct root, or 1 unique root. Okay? So if there's only 1 distinct root, that means that our discriminant is going to have to be equal to 0. Just by writing that, I'm earning a method point. Notice that this is worth 5 points, so that's a method point right there. Then I'm going to go ahead and substitute in for the discriminant. So b is this k minus 3. So k minus 3 squared minus 4 times a is just the k right here, and c is just 1. Okay? Now, the reason IB loves to ask you about the discriminant is because it shows you that it shows them that you understand not only about the quadratic formula and the discriminant and the role that plays, but look at this problem. Look what's happening. It's becoming a quadratic of its own. So they're also getting to see that you know how to solve a quadratic. So our best bet here is to take this k minus 3 and FOIL it out. And then combine like terms. So let's go ahead and continue that. So that'll give us k squared minus 6k plus 9 minus 4k equals 0. So combining like terms, k squared minus 10k plus 9 equals 0. Now, of our three ways that we can solve quadratic equations, the fastest is factoring. So I'm going to check first and see if it factors. And it does. And so we get the options for k are 9 and 1. Notice we should have been clued in that there was going to be more than one answer because they said values of k. Okay, so then it says write down the values of k for which this equation has 2 equal roots. Now when we go ahead and go to solve this, okay, 2 equal roots, again, that's one distinct root, so the discriminant has to be 0. B squared, so k minus 3 squared minus 4 times now a is 1 and c is k. Hopefully you're noticing, and what they want you to notice and not waste time resolving, is that it gives us the same equation as we solved up here. So no reason to solve it again. We get k equals 9 and k equals 1 on its own. Okay? And so they intend for you to recognize that they just basically asked you to solve the same problem. And they want you to notice that and not waste all your time. Notice that it's only 2 marks, so they're only planning on you spending 2 minutes on that. Okay, now let's go ahead and look at a second problem. This problem asks us to complete the square. Okay, and so we're going to go ahead and talk through how to do that. We can only complete the square when our a is 1. So whenever we have a case like this one where our a is not 1, the very first thing that we have to do is factor that a out. And we're basically going to get it out of the way. Now, sometimes it may not factor out nicely, but it doesn't matter. Even if that leaves you with a fraction or a decimal on the inside here, when you divide out that a, you still have to do it because you have no choice. You have to have x be 1. Okay, so we factor out that 2, and then we're going to basically deal with the whole problem inside these parentheses, and the 2 is just going to stick with us throughout all the steps until the very end when we redistribute it back through. So the first thing we have to do is we have to find what I call our square number. Our square number is b over 2 squared. Okay, so b over 2. So b, now that we've factored out the 2, our b is only 2. Okay? So 1 over 2, or sorry, 2 over 2, got ahead of myself there, 2 over 2 squared. And so 2 over 2 is 1, and 1 squared is 1. Okay, so our square number is 1. What we are going to do is inside this parenthesis, after our b term, after the 2x, we're going to go ahead and add our square number and subtract our square number. If we add 1 and subtract 1, we're not changing the meaning of this equation at all. We're essentially saying, well, plus 1 minus 1 is plus 0. We didn't change the meaning. Okay? Now, the reason that this helps us is because what we can do now is we can take this trinomial, and it's a perfect trinomial, and so we can go ahead and factor it into a perfect square. Now, sometimes it's going to be messier and it's not going to look real nice, so don't stress yourself about how to factor that, because it's always going to be x plus whatever this number here is. So that number right there is 1, so it's x plus 1. If that number was a negative 1, it'd be x minus 1. Okay? So it's always that number, so we don't have to worry about the stress of if that was messier with fractions and we don't want to worry about factoring it. And then I'm going to go ahead and take this right here and just combine those. And that makes minus 4. Okay, so now Once I've done that, I've almost gotten it in this form that they want here. But notice in our answer, this 2 is factored out of the whole thing. And they don't want that. They just want the 2 to be right on top of that x minus h squared. So we're going to redistribute the 2 to each term. So we're going to distribute it to this term and to this term. When we distribute it to this term, it's just going to have to sit right in front of it because order of operations wouldn't let us distribute it on the inside because there's an exponent there. And then we distribute it to that -4, and so we get -8. That step right there is the most commonly forgotten step, so be cautious and try to remember that. We have now expressed this in this form, and that's vertex form, okay? And so we are able to do that through completing the square. Same process every time, b over 2 squared, we find our perfect trinomial, we factor it out, and then if we had an a value, we can redistribute it. Now, the next part of this equation asks us to write down the axis of symmetry. Now, the cool thing about the axis of symmetry is it's always going to be through the x value of our vertex, right? No matter where it is. So, looking at this equation, the way that we have our vertex form here, I can tell you right now that our vertex is -1, -8. Okay? That comes straight from this right here. I know that it's -1, -8. Our axis of symmetry is a vertical line, so that's going to be x equals, okay? And the x value of our vertex, so that's -1. If I only wrote -1, I don't have an equation, I just have a number. So make sure you write x equals -1 so you have the equation of the axis of symmetry. Okay, the very last step says express f of x in the form, and that is factored form. Now, this is what I was saying before. To be honest, it's probably not easiest to go from this to factored form. It's probably easier to start back from what they gave us at the beginning, 2x squared plus 4x minus 6. So let's go ahead and do that. 2x squared plus 4x minus 6. Now notice that 2 is pulled out, so we're going to want to do that first. Pull out the 2. Once we do that, all we have to do is factor. Okay, so we get f of x equals 2 times, and we ask ourselves what multiplies to give us -3? Well, 3 and 1, where one of those is negative, right? Okay, and since then what's going to add to give us 2? Well, a +3 and a -1. Once we've done that, we've written it in this form. Now, don't get caught up in how they say negative, negative here. Just because they say negative, negative doesn't mean our answer is wrong, because think about it. Where we have this x plus 3, that's really x minus -3. So don't worry too much about where they have their negatives. Our answer is still correct. Hopefully that gave you a good review on the parts of quadratics that we were kind of struggling with, completing the square and vertex form and then the discriminant. That's all I have. Let me know if you have questions.